mathematical formulation of second law of motion. We are looking at mathematical expression that we can derive from second law of motion. The initial conditions are this. Let's consider an object of mass m moving with an initial velocity of u. Let F be the force applied and for time t, resulting in a uniform acceleration of a. So this is what we are looking at. Initially, right, for time 0, we are looking at an object having some initial velocity. So u is equal to x meter per second. It can be positive, negative, if not 0. And for a time interval of 0 to t, between this time interval, we have a constant force being applied on the object, and so it results in acceleration. Again, it can be acceleration if not deceleration. Suppose that we are not applying any force, so it has a constant velocity. So this is what is happening as per the description. Now, we need to get an expression for rate of change of momentum, because that's what the second law talks about. So basically we need to get an expression for rate of change of momentum, and so we need to get an expression for change in momentum, and so we need to get an expression of initial and final momentum. That is, initial momentum is given by mass into velocity of the object initially, that is u. Final momentum is mass into final velocity, that is v. Just after we stopped applying the force, what is happening? It attains a velocity of v. Before we start applying the force, from the point we start applying the force, it had a velocity of u. And so your initial momentum and final momentum are of this expressions. Now, change in momentum is nothing but final momentum minus initial momentum. This is equal to m into v minus m into u. So what is common? M is common. So we have v minus u. The next thing is rate of change in momentum. That is nothing but change in momentum divided by time. Remember, rate of change in momentum is nothing but whatever momentum we have, divide that with time. That's it. Is it not? So m into v minus u by t. What is v minus u by t? Try to recall, v minus u by t is nothing but a. Let's substitute this over here. If you're not able to recall how we got this, we got it from this particular formula. Okay, so derive it, you will get an expression for a, the same expression. So in place of v minus u by t, I can substitute it to be equal to a, and so we have the change in momentum by time being equal to mass into acceleration. We'll call this as equation 1. Now, the second law talks about this. Rate of change in momentum is proportional to the force. And so we have mass into acceleration is proportional to force. This is from this particular expression, is it not? Rate of change in momentum is nothing but m into a. Right? Instead of this, I can write rate of change in momentum is equal to m into a. And so that I'm substituting it over here, and we have m into a is proportional to f. Now, when you remove a proportionality symbol, we get a proportionality constant. So k is your proportionality constant. Now, what is the next thing? We need to get a value for k, or what they have done is they defined the unit of force, that is Newton, right, to be such that k will be equal to 1. That is, 1 Newton of force is defined to make k is equal to 1. I hope now you have some clarity. We have defined the force in such a way that k will be equal to automatically equal to 1. How did we do that? That is, For an acceleration of 1 meter per second square, for a mass of 1 kg, and for a force of 1 Newton, what we have here is, if I substitute in say 2, if we substitute this into, what will we get? 1 into 1 kg into 1 meter per second square into k is equal to 1 Newton. So when we solve all of this, what will we get? 1 into 1 is 1, right? So k is equal to 1. That's it. Therefore k is equal to 1. This implies force is equal to mass into acceleration. Okay, so with all of that experiment and everything, we just came to this formula, which is something which you guys are familiar. I hope you guys understood the complexity behind it, right? If you understood the experiment and if you think logically, this formula will make sense. If you apply more force, the object will accelerate more. Is it not? If you keep on pushing, it will keep accelerating. That is, it will keep increasing the speed. The most simplest way we can put it, right? Put down or press your acceleration in your vehicle. What happens? The vehicle starts moving fast. As simple as that. That very thing is what we derived. Okay. So again, initially we need to talk about what is the initial condition and draw the respective diagram. Then we need to understand get an expression for rate of change in momentum. For that we need to talk about change in momentum. And when we talk about change in momentum, we're talking about subtracting final momentum and initial momentum. So basically this two. And so end of it, we got rate of change in momentum to be mass into acceleration. Right? But rate of change in momentum is nothing but equal to your force, proportional to your force, as per the definition or description that is explained in your second law of motion. And when we expand all of this, we get the proportionality constant, and we'll try to make it k to be equal to 1. We'll try to make k to be equal to 1 by defining all the factors that is involved in this expression to be equal to 1. And thus we end up with this particular expression. As simple as that. Now you guys have to pause and write it down.